Okay, so tonight we're going to look at how you graph a square root function. So first of all, you should get a general idea of what a square root function looks like, and then we'll look at how it changes depending on the equation. To do that, you should start with the graph of y equals x squared. So y equals x squared gives us a graph that looks like that. We can get a better idea, though, if we graph some points. So let's get rid of this and be a little more careful with it. We know the vertex is at 0, 0. We know that when x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. And then we're off the graph on this side. But we can also get the matching points. Remember, it's symmetrical. So I'm at negative 1, 2, 3. There's 9. So we get this. So this right here is the graph y equals x squared. How is that related to the graph that we really want to find, which is y equals the square root of x? Well, remember last night you did the inverses. These are inverses of each other if we limit the domain, if we only look at the right-hand side of this where things are positive, because we can only pick positive x values to get the positive out here. Okay, so let's invert a couple of points. 0, 0, when we flip the x and the y, we get 0, 0. The point 1, 1, when we flip the x and the y, we still have 1, 1. But this point, 2, 4, is going to become 1, 2, 3, 4, 2. So we'll graph it there. And the point 3, 9, when we invert the x and the y, becomes 9, 3. And we end up with that. That's the graph of y equals the square root of x. Remember, again, we're still only looking for the positive one, so we're not going to do the matching piece down here that we would have last night, which would match up with this part of it. We're just going to, because we want this to come out to be a function, we're going to limit the domain for the original to say only pick from 0 forward, which is going to give us the nice values that we want down here. So for our inverse function, for our square root function, which is what we're focusing on, our domain is going to be everything from 0 to infinity, and our range is also everything from 0 to infinity, because we're going to be able to get all of the possible y values that we want all the way up there by going far out this way. Okay, so that's the parent function. What we want to do now is look at what's going to happen when we mess with the parent function. And you could do that with graphing a bunch of points, but I want you to be able to think about it as taking this graph and moving, shifting it around in the same way that we did with some other functions. So, okay, so let's go to the next slide. Okay, so let's look at what we know about the current, about what we know about things in vertex form and see how that translates to the square root function. So whoops. All right, so let's look at what we know about the quadratic function, because again, this is still related to the square root function with the a and the h and the k. Remember that the vertex on this is hk. The vertex is really the starting point for the parabola. We want to do the same thing for the square root function. Our starting point is normally 0, 0. So the h and the k is where our new starting point are going to be. Same idea behind the vertex. H is going to tell us how the x shifts, and the k is going to tell us how the y shifts, the same way that we did when we were talking about parabolas. And then just like with parabolas, the a value is what I called the slopishness. It's going to tell you how steep it is, and it tells you whether it opens up or down. except that we're not going to call it up or down anymore. We're going to call it right and left. If we have a positive value, what would have opened up, it now opens right. As you can see from the previous slide, when we had a parabola that opened up that way, it turned into a square root that opened to the right. If it was something that opened down, now we're going to translate that into something that opens this way, the other piece of that. So now we're talking right-left. That's our A value, that's our slopishness. X is going to be the right-left shift, just like it was before, of the starting point, and therefore the whole square root function. And K is going to be the up-down shift, just like it was before, moving up and down the y-axis. So, any questions about that part of it? All right, so let's move on. All right, so for this slide here, if we're talking about the black graph, that's our regular y equals x squared. Let's think about what happened now to the green graph. So I'll get some green ink. So for the green graph, we made a shift, y equals. It's still going to be a square root function, but now we shifted where it started along the x-axis. We made a shift right in here, so that gave us x minus -3. We shifted back to the -3, so we end up with the square root of x plus 3. For the red graph, we made two kinds of shifts. We have y equals the square root of, our x shifted to the right 5, so we have x minus 5. But we also had a y shift in here that went down 1, so we need to say that it went down 1. That's outside the square root. We have the square root of x minus 5 minus 1. This part right here shows us the shift in the horizontal shift. This right here shows you the vertical shift. And that's how come this shifted from 0 to 5 and then down 1. Remember that this part we want to have it go back to 0. So if it started at 5, we want 5 minus 5 to send it back to 0. Okay, so now let's look at the yellow one. See if I can find some yellow ink here. Okay, so the yellow one, we have y equals, we had a shift in the y, so we want to stick that minus 2 down here. We also have a square root of x, no horizontal shift, it stayed right on here where it was supposed to be for that, so this is just this x in there. But we need to show that this is now doing the negative, it's going down rather than going up, so we want to do a negative in front of that. It's going to be the negative square root of it minus 2. So we can check that if we were going to take, for example, the square root of 4, something like that, take the square root of 4 in here, that would give us 2, but now we want to make that be -2 minus 2. That's going to bring us all the way down to here. So this is giving us the other piece of that inverse, the flipped part like this. Okay, and then finally, the y1, this didn't shift the x's and the y's, or sorry, didn't shift the vertex, no shift in HK, but it did, let me get that out of there. So there's no shift in the H or the K. What did shift with that is that now, look at the domain. The domain for this one, for the blue, here, is negative values, and that's sort of weird, and the way we accommodate that, since we can still only take the square root of the of positive values, is to say, well, x is negative, I need to make all those values positive, I really need to do their opposite, I'm going to stick a negative sign in there. This is not a is outside the square root, a would be out here, it's going to be inside. So this takes care of like a domain adjustment. It makes things go backwards. Okay, so go fill in the domain and the range, and then come back and check to make sure that you got them right. Okay, so there are the domains and the range. A couple things I want to point out, just note for sure. Check the yellow one. Make sure that you have your range in the correct order, that you're going from the smallest to the largest, that it goes that way. It's negative infinity up to -2 because you're heading all the way up to here and then stopping. And then for the blue one, make sure that you've got the domain is all negative values of x, although the range comes out to be positive. Okay, so here it is summarized in words. If you're going to be graphing some square root functions, look for the horizontal and the vertical shift. So for that, you're really looking for what happens to h and what happens with k. That's the starting, where the starting point moves to, but all the other points move as well. H for horizontal, k for vertical. Look at the slope or the slopishness. Is it positive or negative? How is that going to change the graph? A bigger a value makes it steeper. Here, a bigger a value. And also pay attention to whether a is greater than 0 or is a less than 0, because that'll tell you which piece of it you want. If it's a greater than 0, you're going to get a piece up here. If it's a less than 0, you're going to get a piece down here. And then try a couple more points and sketch. Do they make sense? This will particularly help you with testing for the ones that go backwards, like those guys along the x-axis. Test those, test a couple points just to make sure that it's really working. Finally, we do want to find a couple of special points, so we do want to test the x-intercept and the y-intercept. This is not any different than what you've been doing. To find the y-intercept, you plug in 0 for x. To find the x-intercept, set it equal to y. What is new is that you may not have a y-intercept, you may not have an x-intercept, you may not have either one, depending on what the thing looks like. Be on the alert for imaginary answers for that. So that's the stuff that you need to do in order to do the graphs. Let's try one. So if we're going to forget that the graph is over there, y equals 3x minus 2, you might want to separate that out. Find the black here. There. So you may want to separate that out. That's y, well, you just leave it like this, 3x minus 2. There is going to be no vertical shift because there's nothing out here. There's nothing there. But there will be a horizontal shift. To figure that out, it was supposed to be at 0. So 3x is 2 and x equals 2/3. Our horizontal shift is a shift of 2/3, so we move it over to there. 2/3, if we plugged it back in, would give us a 0 up here. So this is really like writing x minus 2/3 in there. There's no a value, but that 3 does affect somewhat of the steepness. If we want to find an x-intercept, if we want to find the y-intercept, we're going to plug in x equals 0, so we end up with y equals the square root of 3 times 0 minus 2, which gives us the square root of -2. That's imaginary, so there is no y-intercept. So you can see up here, it's not going to cross the y-axis. Now let's try to find the x-intercept. That's where this equals 0. Well, that will happen when 3x minus 2 equals 0, and as we've already seen, that happens at 2/3. So our x-intercept is our starting point, and that ties in with the fact that there was no vertical shift. It should have stayed on the x-axis. And then we'll just pick a couple points. Make sure you try and pick a nice point for this. There's no sense picking something that's going to make your life more difficult. So a nice point for this is one where we can find a good square root. So I'm going to try and make this be, say, 9. So if I want 3x minus 2 to be 9, then that's not, but I'm going to say let's let x be 11/3. It's not really that great, but that enables me to take the square root of 3 times 11/3 minus 2, which is the square root of 9, which gives me 3. 11/3 is almost 4, so if I count over 1, 2, 3, 4, and then that'll take me to 1, 2, 3, that'll give me that point, and then I can finish off the graph. So you should figure out the x-intercept if it exists, the y-intercept if it exists. You should figure out a horizontal shift if there is one. You should figure out a vertical shift if there is one, and then pick a couple of other points to make sure you're doing it right. And then check the domain and the range. Okay, domain and range is probably the hardest part of this. See if you can match these up, and then come back and check to be sure that you're right. Remember that the trickier ones are the ones where there's an x on the inside that's negative, and this is going to be, this is going to be the only one where that happens here, where the x is negative. So that's going to be the only one that goes in that backwards direction. Okay, a couple things that just check to make sure you got the right answers. A couple things I want to say that you should consider. Take a look at if you look at C, that one only has a vertical shift, so the domain is going to stay as x is greater than or equal to 0, and the range is going to shift up to 3, which is why we got that one. Versus D, you're looking at a shift in the x value, so that's the domain. They shifted to 3, because that was what would bring that back to 0, and the range stayed the same. If you look at E, that's the one that goes down that direction, so that one is going to have a range of things less than 0, and then this moves that down so that the range is now less than -3. And then this is the backwards one. So make sure you understand those. If not, write down a question or two, and we'll look at them again tomorrow. Okay, finally, let's do a little bit of practice graphing. If we look at this first one, I'm going to blow that up a little so that we can do the graph. There's a horizontal shift, so my H, okay, that's what I want to look at first, is -7. Remember, it's -7 because it's what will bring this back to 0. So it's -7, -4. My slope is positive, or my slopishness and regular steepness, so I don't really need to worry about that. The only thing I do have to worry about is this HK shift, so I'm going to go put in some axes, leaving lots of room in the negative side. So there's that and that. My graph is -7, 1, 2, 3, 4, 5, 6, 7, -4. That's my starting point. I know that it goes up from there because my slope is positive. But I don't really know where it's going to hit. I don't know what the x-intercept is. I don't know what the y-intercept is. But if I knew those, that would be good to aim for. So if I want to find the y-intercept, that means I should put in x equals 0. So y equals the square root of 0 plus 7 minus 4. Square root of 7, I don't know exactly, but I know that it is between 2 and 3 because 7 is between 4 and 9. So that's, say it's 2.5 minus 4. That's going to give me a -1.5-ish somewhere in here. So I know I'm aiming for that. If I want to find my x-intercept, that's where this equals 0. So x plus 7 minus 4 equals 0. So the square root of x plus 7 equals 4. I'm going to square both sides, so I get x plus 7 equals 16. So x equals 9. That's off my graph. I didn't leave enough room for that. But that makes sense with what I want. I know that it's going to be out here somewhere, and it's pretty shallow, so now I can go fill in the rest of those. And I might want to just test to see if that's right by picking another value in here that's a nice value. So it would be nice to have this be something like, well, 9 isn't going to work. I'm going to need, let's say I tried -3. So when x equals -3, I get the square root of 4 minus 4, which gives me 2 minus 4, which gives me -2. So when x is -1, 2, 3, I have -2, and that's about where I had it. I could probably lift it up a little bit. So I looked for the vertical and the horizontal shifts, I looked for the x and the y-intercepts, and then I tested a point. And then I was able to check to make sure that my graph was okay, and I should probably put in a scale so that 1, 2, 3, so that everyone knows what it is I'm talking about. Okay. So let's come over and look at this one. I want to do the same thing. I'm looking for vertical and horizontal shifts, so I'm looking for what happened to HK. I have a vertical shift of 1, so I know that this is going to be something 1. To find the horizontal shift, I want to set 2x plus 3 equal to 0, because the vertex was supposed to be at 0. I get x equals -3/2, so I'm going to put that in there. That's my HK value. I have a horizontal shift, so back a little bit to the -3/2 and up 1. To find the y-intercept, if there is one, I'm going to say that y equals 1 minus the square root of 2 times 0 plus 3, which gives me 1 minus square root of 3, 1 minus 1.732, which is -0.732. If there were an x-intercept, I'd find them by saying 0 equals. That's going to give me -1. So 1, square both sides. And that'll work if x is -1. So there's my x-intercept. So let me shrink this back down again and go over here and put in some axes. I know that I'm going to want some negative stuff, and I know that I need to shift back, so probably something like this will work. And now when I go to graph it, my y-intercept is down at -0.7, so roughly there. My x-intercept is -1. I know the vertex is at -1.5. 1. And because it had a negative a value, I know that I'm looking for one of the parabolas that, or square root functions that do that, which is good because that's where my points are. So this is going to come down and level off, or do that, not level off, but do something like that. Again, I could confirm with a couple of with a point somewhere. I'm going to pick. There isn't really. Yeah. How about if I pick 3? So if I try x equals 3, then I get 1 minus the square root of 9, which is 1 minus 3, which is -2. So bang on right there. So again, I found the horizontal and vertical shift, or sorry, yeah, horizontal and vertical shift here. Where did the starting point move back to? I found the y-intercept, I found the x-intercept, and then I found a nice point that helped me to graph. Okay, here are a couple other ones to try. You can practice those and then come back and check to see that you got them right. Okay, so you should have gotten these for the graphs, and here's the domains, the domain, the range, the y-intercept, the x-intercept. Make sure that you wrote the range correctly on this one. It's -∞ up to 0 because you're covering all of these and then stopping. There's no y-intercept because if you try and set this equal, or sorry, if you plug in 0, you end up taking the square root of -1. For this one over here, your domain starts at -2 and then goes up, or goes out this way, and your range goes up this way. For the y-intercept, I said, oh, when I plug in 0, I get 2 square roots of 2. I know that 2 is 1.4, so this is going to be roughly 2 times 1.4, which is about 3. Okay, that's it.